Welcome back, Year 7s. It's dissolving and separating. This is lesson 2. Last lesson we had a look at an experiment. We took a number of different substances. We had a look at sugar, potassium nitrate, salt, copper sulfate, alum and copper metal. We added, let's say for example the sugar. We added some sugar to a test tube that was filled with 10 centimeters cubed of water. We put a bung in the top of the test tube and then we shook that for 1 minute. If all the sugar dissolved, we repeated the experiment again. And in actual fact, if we have a look at the results here, we found that sugar had the ability to dissolve 8 spatulas of sugar. So 8 spatulafuls of sugar managed to dissolve in 10 centimeters cubed of water. When we added another one, so 9 spatulafuls, then some of the sugar didn't dissolve. So we don't count that one. Remember, we've been looking at a tally chart and you can see here that we've got a 1, 2, 3, 4, 5 bar gate, 6, 7, 8. Anyway, the different substances allowed different numbers of spatulas to dissolve in them. Now, we got a little bit cut off in the last lesson. So the independent variable, that was the substance. The dependent variable, that would have been the number of spatulas that dissolved. Control variables, we had to keep the volume of water the same. It was 10 centimeters cubed. We had the same shake time. That was 1 minute. The room temperature should be the same as well. And we should be trying to dissolve the same size spatula of the substance as well. So let us move on. Which substance was the most soluble? Well, if we go back very quickly to the table, biggest number was 8. Sugar. Sugar was the most soluble. It dissolved the most easily. Sugar. Which substance was the least soluble? In other words, didn't dissolve very well, and that would be 0. Copper metal. Copper metal. Explain what the term saturated solution means. It is where no more solute will dissolve. It's been saturated. Now, explain fully the type of graph that you will construct. It's going to be a bar graph. One variable is categoric. That's the type of substance. It's best described as a word. And one variable is continuous. It's numbers. Now, complete the graph. You should be able to do this. We've got the substance at the bottom, and then we've got the number of spatulas that dissolved in 10 centimeters cubed of water. Now, if you go back to the results table, the biggest number that we had was 8, and that was for sugar. Always start at 0. Now we're going to go up in 1s or 2s or 5s. Let's try ones to start off with. We've got to get up to 8. 1, 2, 3, 4, 5, 6, 7. It doesn't work. So after 1 we go up in 2s. 2, 4, 6, 8. If you want to, 10 as well. Now you should be thinking about bar graphs now. You need to be using a ruler. The widths of the bar need to be the same, and you need to be identifying what the substance is, whether it's sugar or alum. We've done these before. You should be able to handle a bar graph by now. Use a ruler, please. So let us move on. This is a homework. I would very much like you to have a go at this before looking at the answers. Just copying down the answers is easy. Give it a go yourself. It does not matter if you get the answers wrong, as long as you get the right answers at the end. No problem at all in making mistakes. So give this a go, this homework, on your own first. So 2 cups of tea, one is hot, one is cold. You put a sugar cube into each and stir at the same speed. Which tea, hot or cold, will cause the sugar cube to dissolve the quickest? Surely it's going to be the hot cup of tea. Now, write in the correct phrase in the dotted line. What's the independent variable in this little investigation? I shall highlight them. The independent variable. What did we change? We changed the temperature of the water. What's my dependent variable? What are we going to measure? Well, we're looking at which cube dissolves the quickest. The time for the sugar to dissolve. And then finally, some control variables. Things that we had to keep the same in order for the test to be valid. We had to have the same mass of sugar cube. We had to have the same volume of water in the cup. We had to have the same number of stirs every minute. Now, question 3. The results table below is not being completed. The stopwatch times are in minutes and seconds. So 1.25 means 1 minute 25 seconds. Now you have to convert that into seconds. Now 1 minute is 60. 25 seconds, 25. Add them together, 85 seconds in total. Here's the answers in seconds. The line of best fit for the results, question 4, has been drawn. Add in the 4 plots. So when the temperature was 22, the dissolve time was 116. So there's 22 there. And you go all the way to the top, 110, 12, 14, 16, that's right there. Great. When the water temperature was 37, 37 is here, you're going to go straight up now to 76, to 76, right there. Dissolve time was 56. Boom, go straight up and you get to this point here, just making sure that that is 56, just over there. And the final one was at 76. The water temperature was 40. Yes, we've got that there. That's great. So that was 1 mark each for those plots. Write out a conclusion describing the relationship between the two variables. Well, you need to be using water temperature and the time for the sugar to dissolve in seconds. So, I think I'd be writing down as the water temperature in degrees C increases, so it's going that way, then the time for sugar to dissolve in seconds, what does it do? It's going down. It decreases. I'm going to read it. As the water temperature increases, it goes that way. Then the time for the sugar to dissolve in seconds goes downwards. Yeah, that's right. Okay. Now, the final one today is all about surface area. We have got one big jelly cube, and it is 4 centimeters by 4 centimeters by 4 centimeters. It's a cube. And then you could cut that big jelly cube into 8 more smaller jelly cubes. And each one will be 2 by 2 by 2. Now let's have a go at this big jelly cube right here. The surface area for one side of each cube. So this area here is going to be 4 by 4, which is 16 centimeters squared. Now multiply your answer by 6, because a cube has 6 sides. So it is 16 is one side, but a cube has got 6 sides. So 16 times 6 is 96 centimeters squared. Now multiply your last answer by the number of cubes present. Well, in the big cube, there's only one cube. So it's 96 times 1, so it's 96 centimeters squared. Now watch how the surface area goes through the roof with the smaller jelly cubes. It's odd one. Now to start off with, we want the surface area for one side of each cube. So look, it's tiny, 2 by 2. 2 by 2, which is 4. Okay. Now multiply your answer by 6, because each cube has got 6 sides. So it's 4 times 6 is 24. Great. But hold on. Now multiply your last answer by the number of cubes present. There's 8 of them. So we've got a surface area of 24, but we've got 8 cubes now. And 24 times 8 is 192 centimeters squared. So complete the conclusion using the 2 phrases below. As the jelly cube is cut into smaller blocks, the total mass of jelly in grams stays the same. It remains constant. We haven't increased the amount of jelly. We haven't eaten any jelly. The total mass of jelly in grams stays the same. But the surface area, the total surface area in centimeters squared, look now, it was 96, it's gone way up to 192. As you cut the jelly cube into smaller blocks, the surface area gets bigger and bigger and bigger. So, as the jelly cube is cut into smaller blocks, the total mass of jelly in grams stays the same, but the total surface area in centimeters squared increases. And that will be the end of this lesson today. Well done.